Till now, we have seen basic data types, complex data types, and we had a brief introduction to classes as well. So far we have been using Python shell here. So from this class onwards, we are going to use the text editor. As our programs get more and more complex, we can't do everything in the shell directly. We'll have to repeat the code so many times. So it's better to switch to the text editor. Let me create a new file. So let's where we left off. We have actually created a class called dog, and we created. Okay, let's say we have a class dog. So today we are going to look at how to do extension of this class inheritance and object-oriented programming a little bit. We'll dig deep into the decorators, how the decorators are made, and what is a decorator and everything. So let's say I'll just briefly review what's already happened, revisit what's already discussed so that it's more clear. So a class is a template for an object. So class can have instance variables as well as class variables. Let's say a dog may have 4 legs. All dogs will have 4 legs. All the common properties we will put under the class, and any instance attributes. These are like, this is class variable, and there is something called instance variable, which we will declare inside a constructor. So what is a constructor? Whenever I'm creating an object like this, so this call actually is going to call a function inside this class. Basically, inside classes, the definition of a function is called a method. So let's say init is a default method, which is a constructor. So basically what this init does is it's going to create a new object of type dog. So when I'm defining this constructor, so it accepts self as a default parameter. Self actually refers to the current instance of the object. Let's say this dog object when I'm creating, whenever I'm referring self, that actually means this dog object. Let's say I have another dog, a dog. So this is another instance. When I'm accessing self, that actually in this particular instance is going to be dog. So let's say I need a name for a specific dog. Let's say all dogs will have 4 legs, and each dog will have its own name. So that will be accepted as an argument for this constructor. And how do I define an instance level variable or instance level attribute? Is like this: self name equals name. This actually is going to define an instance variable or an instance attribute called name, and assigns that value that we pass in the name in name. So this name has to be passed from here. Let's say this is something called X. The name of this card is X. Let's say I would name something for this. This one has this. So this accepts name as an argument. So this card, let's just try printing dot name. Let's print dot name. Use both to differ. So let's say, how do I call this script? That is while invoking Python and the name of the script. Animal start. So when I call this declaration is being instantiated by this dog X. looks like in this. So let's say I run another attribute or another method. Let's define another method called speak. Every instance method will accept self parameter as the first argument. Here, I'm going to define an F string. So if we had already seen F strings, I'll just briefly review what F string is. F string allows us to format text. So inside the F string starts with F and then double quotes or single quotes. Within this, I can use any Python expression. Self dot name says. So now let's call the self dot speak function. So inside classes, we call functions as methods. So dot speak is a method. Dot speak. Let's run this now. Let's say spark. This is a spark. Okay, now we have a basic class here. Let's print how many legs. Dot2.name, dot1.name will print its own names. Instance variable. It's going to access the instance variable, whereas legs is a class variable. Let's print dot legs. So dot legs. So when I'm accessing dot legs, it's accessing class variable. Whereas dot.name, it's accessing the instance variable. So similarly, I'm calling a function or a method in classes, we call these things as methods. So dot.speak actually uses its own instance name, instance attribute called name, and dot.speak also uses its own instance variable called name. So that's why using this is not X is not. Even if we had name attribute common name, it doesn't access this name. It actually accesses this name because we are referring to with self. Let's try running this. So if I have to do something like dot, let's access dot name as printed common name. Let's just say we don't do this and then just pass. Pass means do method. So then I'm accessing self.name, and if I don't have an instance variable called name, it's going to use this name. That's printed. So even dog1 has the same name, dog2 has the same name, because we have commented this out. There is no instance variable called name. So it's going to use the class variable itself. If I have instance variable with the same name, it will use that name instead. So in general, we declare the class variables which do not usually change, and for instance variables, we put those things that change based on the object. Similar type of objects will have different names. Common properties, they will put in class attribute like this. So next thing we are going to discuss about inheritance. Now we have seen one small implementation of an object-oriented program. Let's define another class called small dog, which extends dog. So all the functionality of a dog exists for this small dog also, except that it cannot bark. So this part we don't like. Let's just create an instance of I'll come and get this part. Small dog, puts small dog, and I have to pass name to it. And so let's call it small dog dot. We haven't defined any functions, any methods or attributes here. All the things are getting inherited from parent dog class. From this file, where the says block. Even though we haven't done any code here, it's actually using this code from the parent class. Now let's say this is a small dog and I don't want to stop the dog. And the implementation detail, we can do override this specific function in this small dog class. Let's define a function. Spook. And every instance method accepts itself as a default first argument. And I'm going to use string self.name source. And now let's execute this. What will say is I can import. So any functionality that we want to override, we can extend that on the subclass. If you want to use existing functionality, I can use this. Let's just say we need another extra functionality. Okay. And it's not document. Let's run this. So it says I cannot back. Let's call that shape. So this method is implemented only in the subclass, and this is called the subclass of dog. This can be called as a child class or a subclass, and dog can be called as a parent class or superclass. Superclass or parent class are common language, and subclass or child class are common language. So if I do the same thing with the dog object, then we get that dog object. Dog that's dog. Okay, this is a subclass or child class. Dog is a superclass or parent class. So what we have done here, we have declared two class attributes, legs and name. This is the common name. We don't need this. Let's print out this part. So all the dogs will have 4 legs. That's a common prompt. That's why we have defined it inside dog class itself as a class attribute, not as an instance attribute. So the instance attributes or instance variables, analogous, both are analogous. Instance variables or instance attributes belong to only to the instance of this object, this class. So that's why we use self here. So this will vary based on the object. Each object will have its own instance attributes, whereas all objects will have same class attributes. All classes, all dog objects will have the same number of links. And each dog will have its own set of name, age, and everything. So this is about instance variables and class variables. So whereas here we have inherited all the things, all the properties, all the attributes, all the methods from the dog class, which is called the super class. When I'm declaring like this, the super class will go inside the parenthesis. And small dog is an extension of the previous class, which is dog. It's also a dog, but it is a small one. And it has a set of custom functionality or custom features. It cannot bark and it can wag tail. So these two functionalities we added to small dog. So when I instantiated, this is called instantiation. So meaning it's creating a new object of type small dog. So I can call speak functionality or speak method in it, which does execute this code. When I call this method, wagtail method, it executes this code. So if I do the same thing on a super class called dog, the same thing I'm doing, speak and wagtail. Let's run this code and see if that works. Dog.wagtail. Dog object has no attribute wagtail because we declared this method only in the small dog class, not in the dog class. So the inheritance works only in one way. So let's say here, small dog is inheriting from dog. It's not the other way around. If I declare something here, it does not propagate back to the super class. All the things, all the properties, everything, methods, attributes from the super class will be available in the subclass called small dog. But what we define here in the subclass will not propagate back to the super class. That's the difference. Inheritance works only in one direction. If somebody earns money and gives it to their children, it belongs to the children. When the child or the son of any children earn money, it doesn't go back to their parents. That's how inheritance in objects in our day-to-day life also is similar to that. So the wagtail function or method is not going to propagate to dog class. If I use dog class value, for instance, and call wagtail, it doesn't work. So this cannot be called. Whereas a small dog, it works because it's part of the small dog class implementations. So these two are other custom classes. Similarly, we can actually extend existing built-in classes. We have seen earlier by going into the Python shell. And if I type of flow, it is integer and it is actually a class. You see here, this is a class. This is a built-in class in Python. You can actually extend these classes and use them. Similarly, if I do type of 1, 2, 3, 4, this is a type list type of list. List is also a class. So I'm going to extend the list class and implement a custom implementation for the list class for a unique list. So unique list of functionalities is given by the data type set. Sets also do the same thing, but I want to implement it with the list class so that you can understand better to override the functionalities or to override built-in classes also. So this time I'm going to use a class called unique list. This is not the general existing the built-in types, and I'm going to extend the built-in data type called list. So list is again a class. List is also a class. Here I'm going to do class. Means nothing, no implementation at all. All the things, all the properties, attributes, methods, everything gets inherited from list class. Let's try unique list equals list unique list dot append of G. Then parent list. As of now, I haven't done any modifications to the implementation. It's just one to use a token that the class gives. Let's try executing this code. And use that command. Okay. This one, I think you can write this another file. Yes. Back to the fact. Remove this entire code. And yes, that's execute. This one again. Okay, it has added 3, 4, 5, 5, 8. So I don't want these duplicates to be added. So if I add 3, 4, again 4, it should not add 8. Let's do that. No. So unique list, let's modify this code called append function. They're actually calling append method of the superclass list. So in this class, I'm going to override this. So by default, any method, instance method accepts in cell. That should not forget. This time, whenever I'm passing a value here, it's going to come as an argument. So I can put any value, any variable in here. This actually comes as an argument. Apart from self, whatever they pass here will come as arguments. So this item I'm going to use to see if this item exists in the current list item. If item in self. So if you see here, self actually refers to current instance of this list or unique list. So as list is an iterable object, we can use membership operator called in to check whether a particular item exists in the list or not. As we are inheriting from list, all the functionality, all the properties will be inherited by unique list also. So we can do the same in membership operator on the current object, which is self. So this works. If item in self, then don't do anything. Don't add a new item. Otherwise, you have to add the new item to the data structure or into the memory. So that adding the fresh item into the memory or into the list object is all taken care of by the list class. We don't have to re-implement that logic here. We can just call the list functionality to add this new item to the memory. So how do I call the append method of list? Yeah. For that, I need to use a keyword called super. So when I'm accessing super, this actually refers to the same functionality that is implemented in this super object, super class. This is a subclass. This is a superclass. Analogous to this is child and this is parent. Super actually is going to refer to the superclass, which is list, and then I'm going to add the function append item. What this does is it first gets the object reference of superclass and then calls the method append and passes the item group. Just like this method, list also has the append method. It's just we are trying to override the items, the lists append method. So now we just checked if the item is there. If it is there, don't do anything. If it is not there, when I do return, it doesn't continue executing into the next lines. From here, the control actually goes back to here. So return means don't go any further, just return from here. So when I'm finding this element in the list, I'm just returning it. Don't return, don't add, we're not adding anything. If it is not found, this by default actually means else. Don't have to write an else condition here, else statement here, because this control actually will not execute if I'm returning from here. This is unnecessary. I don't need this else. I can just use it like this. So what we did here, we call the superclasses append method with the same argument. So this is just a intermediary that we are checking and adding in. Let's try running this code. Now we have eliminated the duplicates. So in the previous case, we did add duplicates because we are not doing this checks. Our list allows us to add duplicates. And in this unique list, we are not allowing duplicates by checking this. If the element exists already, then add it. And so we just extended the append functionality. What if I want some more properties of this unique list? Let's say I want to have name for this list. So list does not allow us to store any name to it here. So for that, I need to extend the constructor to have instance attributes. So let's just extend the constructor or override the constructor. Constructor also accepts the first parameter as self. And I want to give a name to this list. And I need to pass that name in the constructor as an argument. Name. That name I'm going to use here as an instance variable for unique class. This name I can print as I will have another method self name. This method does not exist in the list class. It exists only in our unique list class, which is a subclass of list. All the functionality from list we are extending or inheriting. We are inheriting all the functionality from list, and we are extending the functionality or overriding append functionality and adding new functionality to print the name and have a name to the list. Let's now print make list and then print before this I'll just print start print name. I'm going to call this method and then print the list. So while constructing the object, it expects the name also. This I'm going to do as my unique list. Run this code. My unique list. So this is one coming from. Okay, this is actually printing, and we are not returning the, or we don't even need to just put print instead of print. What happened earlier, I'll just show. Print of like the start print name. This is actually printing the value, and the return value of print name is none. By default, it actually returns none. This means even though this line is not there, it actually means it's returning none. And as it returns none, that value is getting printed by this print statement. That's why we are saying this none. I'll just remove this print statement and just call print name after now execute my unique list. This is how we extend the built-in classes. You can do the same thing with dictionaries or any other data type. So to demonstrate even further in inheritance mechanism, let's take another example. Let's say I have shape start, right? I have a class called shape, and shape has two attributes. Right? Let's say initialize of 5. Right? It's 5. Let's print, define a function called print, which accepts self as the first argument. And what I want to do here is for every line, for every width, for every height, meaning let's say 5 square feet by 5 square feet, I want to print a specific character in the terminal. Let's say 5 rows and 5 columns. I want to print a star 5 times on one row, and I want to print 5 rows with 5 stars. That becomes a square. And for triangle, so first line will have 1 star, second line will have 2 stars, third line will have 3 stars. That becomes a triangle. If I print and show you, that will be evident. So we'll just assume that. For now, let's implement it, and then we'll revisit this. But if I want to print a shape, what I have to do is the height of the shape is, let's say, height 5. For each line, till the height becomes height, I want to print a character, print row of height. Self, I haven't implemented this method yet. So for each unit in height, I want to print one line. Let's say height is 5. I want to print 5 lines. 5 lines with stars. How to print the stars is handled by print row. Let's implement that also. Print row. This also accepts self as the first argument, and row number as I accepts. And then I have to print a row based on the shape of the object. So now I can't do this here because I don't know the shape of the object. If I have to print a square, I should do the all how many stars I need to print is evident. The same number of stars as the width. So height we know. For square or for triangle, the height we know. The width of the characters that will be part of the child class. So let's say this, I'll raise an exception If somebody calls this exceptions, I will discuss in a bit. For now, this is not implemented exception. So if somebody calls this method on the base class call shape, not implemented error, this implemented silent class. This is the base class. We have attributes, one common method which will get called for printing. In print, how to print based on shape of the object, how to print that will be decided in the subclass. So let's define another subclass called square that extends shape. So this class only implements print row. Everything else will come from the shape object itself. Print row, how to define? Yes, self and I. Each row I want to print, for each row I want to print a character. That's a very star character. I want to print, and I'll just use hash. How many times I want to print is self width. Based on the width, I want to print this. Let's say this hash character also we will just move it to the parent class. And add as a print character as hash. And I'm going to use that itself here. So that print character. Just self that means it's going to print hash symbol 5 times if the width is 5. For each row, if it prints 5 times, second row 5 times, third row 5 times, fourth row 5 times, fifth row 5 times, that will become 5 by 5 matrix, which is like a square. So that's how about this shape. Let's just execute and see this square. This square. Square. Yeah. Run this flow like that. Shape stack v1. It's painting 5 by 5. Although it looks like a rectangle, but it's actually a square. 5 rows and 5 columns. 5 rows and 5 columns. Let's implement one more class called triangle. Similarly, and it also extends shape. So same thing, I'm going to override print form, but this time it's going to print first line 1 character, second line 2 characters, third line 3 characters, and so on. So based on line number, so right. So print character into I plus 1 because I starts from 0. Here, if you see here, the range function 5 program range 100 5 to I'll just convert this into a list. It starts from 0 till 99. So when I'm referring to the height, it's actually starting from 0, line number 0 to line number 4, as the height is 5. So that's why I need to do a plus 1 here. How many times? First row, which is 0th index, you should have 1 character. So do the same thing with this triangle. Triangle. Then shapes everyone. This got it. Let's come out of this once. So confusing. It's clear. It's not going to be a right angle triangle. So this is not a triangle. Let's do one more example. Instead of right angle triangle, I want a symmetric triangle. So this one is 1. And second row will become 3, left side 1, right side 1, middle 1. 1, 3, 5, 7, 9. So let's write that code for a symmetric triangle. This also extends from shape. Row. This has self as the first argument and line number as the second argument. That line number starts from 0. The line starts from 0. So I'm just going to pass. So for symmetric triangle, the height has to be same. 5 is fine. So if I have to print a symmetric triangle, it comes from this way and right side this way. So the bottom line will have 10 items or 9 items. So we need double the size of the height. So that's why I'm going to override the properties in the class itself. So width we have, height we have 5. That is common, no problem. Width is going to change as we are going to scale from here to here and here to here. The width of the bottom one will be changing and each row's width also will change. So if I take the matrix of 10 by 10, then I can fit the triangle. Let's solve it. So I'm just going to initialize this with 2 times 5, which is the height, 2 times the height. Okay. So for each row, I'm going to find out the width that it occupies, a specific row, how much it occupies. I'm going to initialize a variable called row width. Row width is going to be first line, it will be 1, 2, 3. Or with character. That's character. So first line is going to have one item. That's fine. Second row will have 3 items, 3 hash symbols. Third row will have 5 hash symbols. Fourth row will have 7. Fifth row will have 9. And so on. This is actually an odd number, right? We are increasing by 2. So for generating the odd numbers, I'm going to use one number into 3 plus 1. So when I is 0, it will be 1. When I is 1, it will be 3. When I is 2, it will be 5. When I is 7, I is 4, 3, it will be 7. When I is 4, it will be 9. So that way, character width will be separated correct. So first row will have 1, second row will have minus 1. So for printing this character like this, there should be a padding before the print. Hash symbol should be printed in the middle of the triangle. First row, as we are conscious from here to here and here to here. So I need to find the padding. How many offset I need to add? Padding, I'm going to use self dot width. So because its overall total is 10 by 10 matrix, width divided by half. If I do this, it will fit for 1 character. If I am fitting 3 characters in the second line, that's going to that's not going to be correct. So for that, I have to actually reduce the width by how many characters we are printing. Character width. This entire thing has to be divided by 8. So when I calculate total number of characters. By characters, it will allow divided by 2. The left side, that much I should leave, and the right side, that much I should leave. So that is 1 divided by 2. So I'm going to convert this entire thing into an integer, because by default, if I do divided by, it will generate a floating point number. So now I will do the print statement. So padding, I should give spaces. How much padding I need to give is this. I will print this my number of spaces, and then I will print the character. Print characters. So print characters. How many times I need to print this character? The first row, I need to print 1 character. Second row, I need to print 3 characters. The offset will be the total width minus the number of characters I need to print divided by 2, because that is the number of characters I need to shift from the left. When I run this code, here, now I'm going to visualize symmetric clown. So, let's run this code. Now it's printing a symmetric triangle. If you see here, this is almost 10 characters, 9 characters, 1 left. But so this is a symmetric triangle. This is how we take this calculation. Any doubts so far? So next thing we have to discuss is the exceptions. Let's try doing this 1 divided by 0. Python exceptions, and it will through an error, 0 division error. So by default, this is mathematically impossible. 1 divided by 0 will be infinite, and computers does not allow these operations to be done in the CPU. So that's why we return an error, divided by 0 error. This is a common error. So this gives us the stack trace. This is called the stack trace. How or when this is called and from where this is called. It says that exceptions.py line number 1, we have called this, and this caused a 0 division error, division by 0. The explanation of that error is given. Is given. So what if I have this inside the function as error? This line error as error from input. When I execute, there is 2 stack traces. On stack trace, 2 lines. So we have called cause error on line 4, and it resulted in 1 divided by 0. So division error. Earlier we had only this error. And if I have another called cause error, another redirection, instead of this, let's call times error again. There'll be 3 stack traces, 3 lines. So what's the stack trace? Like from which code are we calling this particular error? So how does this error happen, and from where the code is getting called? This is the system stack trace. So that's about exceptions, by default exceptions in Python. So when this happens, when any exception happens, the program halts. Halt means wherever it was executing, it will stop executing there itself. Doesn't continue. So there is a way to gracefully handle these errors. If any error happens, a program will crash and the server, let's say, if the server got into some kind of issue, it won't recover. It will crash the server and it will shut down the process. That is not what we need to do. We need to gracefully handle these errors. If any unknown errors happen, how do we gracefully proceed with the code so that it doesn't fall down? So for handling that kind of error scenarios, we use a special statement called try and except. Some error happen. If I call it this way, this doesn't work. Program doesn't crash. The exception occurs and the problem will be, this statement will be printed and program still executes. Let's try again. Before implementing this, let's just run this code and try to construct it. This is after exception. So when this exception happens, and this line does not get executed because it comes out of the program logic. So that statement doesn't get printed. So what if I have tried and except block here, exception, error happen, and this statement also gets executed after handling. So because some error happened in this call and this statement got printed, and program continued execution with the next statements. This is how we gracefully handle these errors. Suppose we have this exception. What if I want to execute some code whether or not exception happened or not? So with that code, I will put in a finally block. This code always puts. So when an exception happens, this statement gets executed. If there is no exception, this statement does not get executed. Whether there is an exception or not, this statement is always going to get executed. Let's try to do that. So exception happened, and this statement got executed, and this also got executed. This code always gets executed. Let's just do something like 1 divided by 1. Now 1 divided by 1 will not cause any error. Let's run it. And it did not cause any error, so this statement did not get executed. And this statement got executed because it is finally blocked. No matter what, no matter whether exception happened or not, this should always get executed. And then the program continued. So that is one. Now I have, let's say, if I want to know what type of error I'm getting, I can just say exception as this can be emulated or any variable. I just catching the exception in this variable, and I want to print the type of exception. The type. We to type here. This actually was going to print this exception 0. So some error happened, the class of 0 division error. So I can handle specific. This is a generic exception handler. So I can handle specific type of errors. Let's say I have this one plus a. This is another type of exception. Let's try executing. This is a type error. So this code can get into any type of issue. Let's just say n. This, let's add this code as 1 divided by n, and 1 plus, let's write this code above this line, 1 plus n, 1 divided by this. So this n can be anything, we cannot trust who's calling this function, and n can be 0 or n can be a character on anything. So I need to handle type errors, which happens when n is a character. I need to handle zero division error when this happens when n is 0. So let's handle those specifically. So any specific exceptions we need to write before this generic exception handler. Let's write except zero division error and zero division error happened. Similarly, let's write another block that handles type error. Type error. Okay. If none of these things match, the last one, exception generic handler, will get triggered, and always the final block gets executed. Now I'm going to call this cause error with, let's say, 0. Zero division error happened. Okay, I'm going to now call it B. Type error. So this is how we have different types of errors in runtime. So now, every time if we have to handle these type of errors for every function call, that becomes a tedious job. And there is an easy way to implement a common functionality that we can wrap this entire thing into one decorator. So decorator is a special function. The decorators are used like this. Handle exceptions. This is a decorator here. So a decorator starts with at symbol and the name of it. So this decorator is not yet defined. This is a custom decorator that we are going to implement. So how do I implement this decorator? It's like this. Def. This is another function itself. This accepts a function argument function and has another function inside it defined, something called wrapper. This can be any name. For now, I'm just going to do a pass here and then return wrapper. This is all we have to do about a function wrapper. So decorator. So inside this wrapper, we are actually going to call this function. This is all we need to do to handle exceptions. Let's we'll implement that. This is all we need to do for declaring a decorator. So this is throwing an error because as Python is a step-by-step procedural language, we should actually define this above this line. So till this is defined, this code cannot access this particular code. So now as I move this decorator outside or above this line of code, so now the error is gone. Okay. Now this entire functionality of exception handling, I'm going to move this thing inside the handle like this. So I accept what I'm going to use some direction from here to here. Just doing this. I'm going to use that here. Now when I call this cause error, I'm just going to use cause error directly. Stuff here, I'm going to move this to cause error. I'm just doing this one. So let's move the around. Now I'm going to call directly this cause error. Okay, that's fine. We have this. I'm going to demonstrate with one of the exceptions. We call cause error. That's fine. Now, if I do this, I will get by default all that exception handling will be handled by this guy. When I'm handling exceptions inside the decorator, I can call it, and all the exception handling call is inside the decorator. And I don't have to repeat for every function. Any function that needs to handle all these exceptions can be wrapped under this decorator under exceptions. Okay, that's on them. So now let's say I'm going to call cause error directly instead of calling this. I'm going to use handle exceptions here also. But cause error actually accepts an argument, and we are calling that function without an argument. There is showing cause error exception. It's showing an error. Let's execute on second. So cause error invalid syntax. One sec. Cause error. Okay, so the cause error is not defined. We are actually calling the function, not the definition. So let's move this cause error also. And same thing, I'm going to use exceptions on the cause error tab instead of this. Now I'm calling cause error with view as an output. Let's try it on this. Handle exceptions takes 0 position arguments, but 1 was given. This is because we are passing u as an argument, n as an argument to cause error. So when in this annotation or the decorator, we are passing a function and we are not passing an argument here. So we should actually pass the arguments also. To get away with this problem, we have to pass in the arguments as args. The function that pass args. This works. Let's try run this. Hyperrun happening. And this is able to handle the exceptions. This is how we write custom annotations. Annotations in the sense decorators. Decorators and annotations are on the same. Yeah, that's about decorators.